Jack Sarfatti's revolutionary ideas on physics, consciousness, and UAP propulsion. This is a clear, spoken summary of physicist Jack Sarfatti's key ideas, drawn directly from his papers, such as Destiny Matrix, Supercosmos, and recent AR-14 preprints like Emergent Gravity from Conformal Field Theory, his academia.edu posts, YouTube lectures, and interviews. The goal is to explain complex concepts in everyday language, with rich details and real-world examples, so listeners can follow easily. Roger Penrose laid crucial groundwork that Sarfatti builds upon. In the 1960s, Penrose invented twistor theory, a completely new way to describe spacetime. Instead of thinking of events as points in ordinary four-dimensional space, 1 time plus 3 space dimensions, twistors treat light rays as the fundamental objects. The mathematics lives in a 6-dimensional auxiliary space with signature plus 2 time-like dimensions and 4 space-like. This allows the full 15-parameter conformal group, so 2-4, to act linearly, compactifying Minkowski space and adding conformal infinity in an elegant way. A key tool from Penrose is the Penrose-Ward transform, developed in the late 1970s. It shows that complicated nonlinear self-dual Young-Mills gauge fields in ordinary spacetime correspond exactly to simple holomorphic vector bundles on twistor space. This has been hugely important for understanding instantons, topological solitons that help explain quark confinement in QCD. Penrose also discovered aperiodic tilings in 1974, patterns using just 2 shapes, fat and thin rhombi, or kite and dart, that tile the infinite plane perfectly but never repeat periodically. They have 5-fold symmetry and self-similar structure based on the golden ratio. These tilings directly inspired the discovery of real quasicrystals and materials, like alumina-manganese alloys, for which Dan Shechtman won the 2011 Nobel Prize. Jack Sarfatti argues that Einstein's 1915 general relativity is incomplete. Einstein only gauged translations, producing curvature but leaving out torsion. Sarfatti extends this by locally gauging the full 10-parameter Poincare group, translations plus the 6-parameter Lorentz group, within Penrose's larger 15-parameter conformal group, which is the maximal symmetry of flat Minkowski spacetime. This extension introduces propagating torsion fields sourced by quantum spinors, essentially, twisting of spacetime in addition to curving. Torsion had been neglected in standard GR, but Sarfatti shows it becomes crucial when symmetries are properly gauged. The foundation traces back to M. E. Noether's 2 theorems of 1918, which Einstein did not know when formulating GR. Noether's first theorem says global symmetries lead to conserved charges, energy, momentum, angular momentum. Her second theorem says that when you make the symmetry local, allowing phases to vary arbitrarily from point to point, you get local conservation laws expressed as vanishing covariant divergences, and compensating gauge fields appear. These theorems hold rigorously only in the microscopic vacuum where light propagates at constant speed c, independent of frequency or direction, the non-dispersive regime below the Schwinger critical field, about 10 to the power of 18 V/m. Above that intensity, the quantum vacuum behaves like a dispersive medium, producing real electron-positron pairs. In macroscopic engineered materials, fundamental Lorentz symmetry is spontaneously broken. As Nobel laureate Philip Anderson famously said, more is different. Condensed matter physicists almost never perform Lorentz transformations, they work in the material's rest frame, where calculations are simplest. The local differential equations of fundamental field theory give way to non-local integral equations with dispersive Green's functions, exactly the regime of modern spacetime metamaterials pioneered by researchers like Christoph Kallis. Sarfatti's breakthrough insight, developed over decades, is that in specially pumped nano-engineered metamaterials such as Froelich coherent condensates, polariton systems, or topological Ennian lattices, the effective quantum gravity scale enlarges dramatically. The fundamental Planck length of 10 carat minus 33 cm and energy of 10 carat 19 GeV effectively inflates to nuclear scales, around 10 carat minus 13 cm and roughly 0.008 GeV. This low energy window makes quantum gravity engineerable with today's or near future technology. By coherently pumping the metamaterial, for example, with terahertz or optical fields, resonant phases emerge, attractive curvature inside, redshift, repulsive anti-gravity outside, blue shift. The result is a controllable metric, essentially a warp drive or traversable wormhole without needing exotic negative energy density everywhere. Sarfatti proposes that the fuselages of observed UAP, such as the 2004 Nimitz Tic-Tac, function as such gravitational metamaterials. Their observed behavior matches precisely: near-instantaneous acceleration, thousands of Gs without crushing occupants, no sonic boom, transmedium travel, air-to-water seamlessly, low observability except for plasma glow, and occasional interference with nuclear systems, as documented by Robert Hastings in UFOs and Nukes. In Sarfatti's post-quantum theory, the quantum wave function acts as a mind field capable of direct back reaction onto classical structures, violating the usual no signaling theorem. This provides a physical mechanism for consciousness, extending Penrose-Hameroff orchestra and for retrocausal effects that could explain apparent intelligence and evasion in UAP encounters. Finally, Sarfatti ties this to John Wheeler's It from bit vision. Physical reality emerges from quantum information bits, with EPR entanglement corresponding to ER wormhole bridges. In engineered metamaterials, these bits become macroscopically coherent, allowing conscious control of spacetime itself. In summary, Jack Sarfatti's work presents a testable, engineering-friendly extension of Einstein and Penrose, low-energy quantum gravity via torsion and conformal gauging in metamaterials. UAP phenomena are not interdimensional fantasy, but real demonstrations, likely human breakthrough or advanced visitor technology, of metric engineering made possible today. This framework is laid out in Sarfatti's books, papers, and public lectures. It offers a coherent, falsifiable path from fundamental theory to observed high-strangeness events.